At the time of this recording, the following content is considered proprietary and non-public, and should not be shared outside the intended viewing audience. Deckard is an AWS-based serverless platform for robotic and agentic workflows and services. The services is crossed out as it is not its intended purpose. It has a CloudFormation deployment, so it is a quick and easy install. There are 0 third-party dependencies, unless of course you count AWS. Has a extremely small footprint, very little code debt. It is built to run on the Node.js Lambda runtime. It is opinionated but loosely enforced, which means you can choose how you want to achieve the things. It is built with orchestration and choreography in mind, or some form of those, and it has dog-fooded features, which means part of the platform features are actually built on top of the platform. ALF, or ALF, is an activity-based workflow framework. It is at the heart of the Deckard platform. The ALF can stand for whatever you want it to stand for. It uses a DLS-like code. Instances are isolated in their own runtime with their own active state. That's a side effect of the Lambda runtime, but also as design. A client prompts Deckard to call replicator run an ALF definition. And an ALF performs activities, as we had mentioned, that optionally uses skills, tools, and services. That optionally is in heart of the highly opinionated or loosely enforced. This is a three-dimensional graph of the spectrum of an ALF. See, it is metriced out by autonomy, independence, and scope. The idea is as you increase those, you become more agentic-like. Decreasing those, become more bot-like. This isn't to imply that bot-like is bad or agentic-like is better. In fact, as you increase your autonomy, independence, and scope, you run into a very dangerous situation as you have less guardrails on your workflow. So there is a sweet spot to be found. Brando is the template engine of the platform. It was originally the genesis of Deckard. Deckard was originally meant to be a prompt engineering tool for models. When interfacing with models, it works on a prompt and parser pipeline, but it also is used by the platform for doing dynamic code generation for your ALF, your skills, your tools, your services, etc. It is also used for the HIDL page generation, which is a human in the loop. There's a very special way that Deckard handles this, and there's an API for direct use of it within your ALF. Peak is the interface to the memory and state of the runtime in your ALF. It's a low-level feature. There's a concept of working memory and long-term memory, and the idea is that memories are implanted in an ALF instance, which could be new memories or stored memories, long-term memories from other ALF instances. And the idea is that ALF instances are ephemeral, but state and memory is lasting. MacGyver is the interface for building skills, tools, and services. We'll get into that into later presentations. But the idea is that skills, tools, and services are layers of abstractions that allow you to reuse workflows, code. Tools are a special concept in agentic workflows, so when you move across that spectrum to be more agentic-like, tools have a specific meaning. Using these is a recommended approach, that is the opinionated, but it's not required. You do not need to use these to build things. Auto is the repository system. It is actually a very low-level feature of the platform. Is the engine that manages your components. There's an idea of the vault, which is in-memory caching of things. There's also local cache on disk, and the main what we call depository is stored on externally to S3. It is actually used by the peak memory system to store your long-term memories, and itself uses Brando for code loading, dynamically creates code with template engine, and it actually uses MacGyver's tool for S3. And you can also create custom depositories, which is an advanced topic. Ouija is the interface to models, specifically LLMs. The idea is you define a model config once and done, so you can repurpose that across your ALFs. There are two specific interfaces built for AWS, the Flintstone interface, which is for Bedrock based LLMs, and there's Saviel, which is the SageMaker endpoints, which are a different type of way of working with LLMs on AWS. It actually uses Brando for itself for the prompt engineering, the prompt and parser pipeline, which I had mentioned, which allows you to do customized prompts and parser templates. And it actually uses MacGyver for its services integration to the LLMs. Nixon is the audit feature of Deckard. There is a concept of a listening tracing file, which is a JSON line file, and it records all actions. So the idea is that you know everything that your ALF tried to do. It's very verbose. There's also a hook into CloudWatch for logging, and a hook into AWS and SNS for notifying, and that's specifically used for HIDL and async calls, which is built into the platform, but you can also repurpose that. And Broadcast, which is a hook into AWS Event Bridge, and one of the out-of-box solutions there is for genealogy indexing, which is an advanced topic we'll talk about later. And it itself uses MacGyver as well for services integration to those above mentioned services. So another example of dogfooding. Kilmore is allowing you to do configurations, basically your secrets, which and configurations, which are both encrypted on parameter stores, so you're not storing those things within your code. It is built for encryption, authentication, authorization. That is to be determined how it's going to handle that, but we do out of box you get all the AWS stuff, right? Encryption, authentication, authorization. You get all those from the services, and it is used by the Deckard runtime. But there's also an API for custom use that allows you to store your secrets and configurations. Darwin is a very low-level piece of the platform that you won't necessarily integrate with directly, but it allows you to do genealogy generation dereference for the ability to store long-term memories and restore long-term memories and do implantation to your Deckard. There's things like DNA and ALF-ID and lineages and traits, which are part of that. There's an ID for dereferencing, so it can find the appropriate state or long-term memory to recall, which is a term that Deckard uses. And the idea here is the genealogy can also be used for graphing of the flow, which gets back to genealogy indexing, which is not a core part of Deckard, but it actually is an add-on to Deckard, and that is another advanced topic. So what's the future direction of Deckard? Eventually there will be an IDE and a full admin dev UI built on top, so it will not be part of the platform per se. It will be built on top of the platform. These aren't required to actually utilize the platform. And some ideas of solutions to build on the platform is RAG, which would also use something I call Brasco, which is embedding and vectorizations, which may actually become a core component of the platform. And one thing that's pretty exciting is using desktop control, using Apache Guacamole as the UI API and LLM for tool selection, computer vision, but using Deckard to use the orchestration and the choreography of that. So what are the key points, key takeaways here? Deckard is serverless. That's very important to understand because it seamlessly scales. That means whatever size your workflow, it will scale with it. There's no infrastructure to maintain. It's a platform, which is very important to understand. It's not a solution, but it's ready to go. Once you install it, you can start building. It is open source, source in quotes because that's not necessarily a licensing term, but There is no black box. Everything can be seen, all code. Built on itself means it's designed for usability. You can go at your own pace. You can create simple jobs, services, very simple Lambda-based executions, all the way to very rich agentic workflows. And it's extendable, which is come back on that build on itself. You can customize on top of it, and the build on itself usability that it has out of box is an example use case that you can look to understand how to build on Deckard.